right? Now, we will be dealing with the blockchain, and as I mentioned, Mandla Magagula will just introduce himself, right? Please so, and then he is well experienced in the field of ICT, and of course, in particular, blockchain. He will really paint the picture to us what that blockchain is about. Thank you for making time for us, and please take over from here. Thank you.
All right. Thank you so much. Thanks everyone for joining. I'm so thankful for this opportunity. Motlokwe, can you just allow me to share my presentation?
Yeah, you can share, I think, now.
Thank you so much. I appreciate that. Let's see. This is the one. All right. I'm hoping everyone can just one of you confirm if they can see my screen.
Yes, we can see. Thank you.
All right, perfect. Yeah, it's very hard to introduce myself.
We are losing you a bit.
By the way, I'm Mandla Makakula. I work as a blockchain solutions in South Africa a bit. Can you hear me now? Let me slow down. Can you hear me? I do apologize for that. I'll really ask that we mute ourselves when we join.
Okay, I'll do it from my side here. Yeah, I will manage that from my side. Yeah, thank you.
That'll be great. I appreciate that. So the intent of this conversation, of this presentation, is just to get an understanding of what blockchain is. Maybe you've heard the hype, you've heard in the news people talk about blockchain, talking about cryptocurrencies. I will not focus very much on the cryptocurrency side. However, I will touch on it because it's very difficult to talk about blockchain without talking about cryptocurrencies, especially Bitcoin. However, the use cases of blockchain and the opportunities are actually much more deeper than mere cryptocurrencies. Cryptocurrencies are important because they store value and a means of exchange in terms of value exchange from one individual to the next. So I want to start by saying this. You know, just think back. I don't know, most of you were still young at the time, but my first interaction with the internet was back in 1995. It was dial-up connection, and my teacher at the school that I was in, he was forward thinking. I miss him a lot, Mr. Matthews. He was forward thinking. He bought this one computer and he bought this little dial-up modem, and he basically brought it to one of our classes. Like, look at this thing. This is the internet. This is how the internet works. And at the time, to me, it just didn't make sense. Like, why would you need that? Why would you need computers to be connected? But I was not alone. I think there were many other people that, why would I want to look up information on the web? Why should I trust the internet? And things like that. But so if you think back 1995 and today, right? So where we are today, we're pretty much in, I would say, 1997 of the internet when it comes to blockchain. Just understanding the use case and the vast opportunity that blockchain presents. So I have this picture that I usually share when I give talks. Like, look at the ecosystem, look at how the map grows. I have stopped doing that because it changes so vastly and so significantly within a short space of time. This picture doesn't even begin to showcase the number of ventures and companies that have sprung up since the advent of blockchain technology. So if you've been looking elsewhere, I think this is an opportunity for you to start looking into this space. And I have another one, exactly, which builds on the previous picture, and it's just saying, now there's another element which we call the decentralized finance, which is another area of blockchain technology, especially Turing-complete blockchains. I'll explain what Turing-complete blockchains are, which basically talks about taking traditional financial instruments and replicating that on a decentralized network. All right, so you're sitting there and asking, okay, Mandla, you've been going on about this blockchain, but I mean, I'm here to understand what is this blockchain? What is blockchain? So depending on who you're talking to, depending on where they come from, you'll get different descriptions. But this is my description of what blockchain is. And I have intentionally, if you're looking at the same man, that you're breaking grammar rules and etc., putting capital letters in the mid sentences and stuff, that's okay, because I want to highlight that. So the things that I've written in uppercase, actually things that you should remember when you think of blockchain. Number one, it's a digital ledger. So it is not a physical ledger like that you see in books. And I'm working with the assumption that people understand how a ledger works. About inflows and outflows. It's about showing value, as value is value transfer, in chronological order. So it faces a digital ledger maintained by a set of validators that remains correct, even if some of the validators, well, in this case, it must be less than a third, are malicious. So again, I've highlighted malicious there because we're saying that we don't have a stick, like in blockchain terms, on this digital ledger that's decentralized with a set of validators. If some of the validators decide to be malicious, we don't have criminal proceedings against them. The network itself will know how to spit them out, how to say, we'll still proceed. We're not stuck just because we have one or two bad apples on the network. And the other key thing that you remember about the blockchain is that each party or each participant on a blockchain network keeps a copy of this ledger on their own computer. So if I'm in a blockchain with everyone in this call, so each one of us will actually have a copy of this ledger, the exact same copy. I have a copy, Motlokwe has a copy, and everyone else has the exact same copy of this ledger. And then we have a view at any given point in time. So you don't trust me for my transactions. You actually say, okay, based on my ledger, I have the exact same copy with everyone else. So you don't trust one individual with keeping score and making sure that which transaction is valid on the ledger. I'll talk a lot about transactions because that's exactly what blockchain is structured. It's structured in terms of transactions that are grouped together as blocks that are linked together in a cryptographic hash that if you try to change any part of the blockchain, basically the whole blockchain, the whole chain of blocks from the beginning of time need to be revalidated again or remined to get the blockchain in a good state. The main benefit, as I've already mentioned, of blockchain technology is the ability for parties to share a ledger without having to rely on a central authority. Think about a banking system. If you want to send money and you're banking with the blue bank, you want to send money to someone that banks with the green bank in the South African context, you almost have to trust those banks with their ledgers to say, hey, I hope, and you trust that they're keeping that ledger secure. You trust that they're not entering or adding additional transactions on your transaction or on your request, right? So you trust them by virtue of who they are. But blockchain actually takes that and says, no, you don't have to trust these people by virtue of who they are. You trust people based on the mathematics, based on cryptography. And one other thing that's very important about blockchain, about this digital ledgers, is that they are decentralized. Decentralization means that they are not in the same geographic location. They are not under the same institution. So if we're in a blockchain network, it means that each one of us keeps a copy of the ledger, and we're not in the same house, right? Because it becomes ridiculous that you have a blockchain of people that are in the same house, because then it means that someone else I can have access to your blockchain and then change transactions to your ledger. So ideally, when you talk about blockchain, in nature, they have to be decentralized. I've heard of many companies saying we're a private blockchain. Okay, why do you need that? Doesn't make sense. Use a database. It's too expensive to have a blockchain and you're a private company. Okay, I'll stop here for a second because I've been speaking for 10 minutes. Do you have any questions?
Yes, definitely. There's a question from Telly saying, in a simple term, what is a ledger?
Right. A ledger, it's a table or it's a log of transactions. It's a log that shows inflows, what comes in, or let's make an example with Manda, right? So let's say I want to pay you money, then I will write in this document or in this table that says, on this particular day, I paid Telly this amount of money, right? Let's say tomorrow you decide, okay, maybe you want your transactions to be on my ledger as well. So you decide to send me some money to pay me, then I'll go on that ledger and say, okay, now on this next day, Telly sent me this amount of money. So which means together, these transactions, when you combine them together, they basically lead to a single value, which you can trace back based on the activities on that ledger. So it's basically just like a log, like a big log of inflows and outflows of transactions or value or payment, like in this case, like when a transfer of value, when you send money somewhere, you keep a history of that. This happened now, this happened. That's basically what a bank does. When you move money out of your account, your checking account or your savings account, it actually becomes part of the ledger. It goes like from this account number, take this value and send it to that account number. So there's a sender, there's a receiver, there's a value, so which then means that, and then obviously because of subtraction, the account balance is impacted by that activity. That's what a ledger is. Any other question? All right, should I proceed?
Yeah, I think so.
Okay. Now, how did we end up here? How did we end up here? So I always want to paint the picture of blockchain. Oh, everyone thinks, okay, great, blockchain started in 2008. No, that's a lie. Blockchain started way before because of the advent of the internet. In 1991, a gentleman called Stuart Haber, at the time, they wanted to solve this thing called a time stamping document to improve integrity. So what does that mean? So one thing about the internet right now, it's not easy to validate when or to tell when something happened. Have you seen in most cases, for those of you that are on Twitter, and let's say something is trending or maybe it's something that's polarizing. All right, I thought someone was saying something to me. All right, something that's polarizing, especially on like polarizing subjects. Someone will go and take a video that was shot maybe like in 1890 something, and upload that. Okay, this just happened yesterday, right? And people that don't want to validate to see how true that is, they don't care because they take that video itself as the truth. And actually, that problem was recognized many years ago by Stuart Haber and his colleagues, that it's very important that in the future of the internet, we need to be able to timestamp document and have a digital fingerprint of those documents. This we call a one-way hash. And that piece of work actually played a big role in 2008 when the pseudonymous character called Satoshi Nakamoto submitted the first white paper for a peer-to-peer electronic cash system, which you know now as Bitcoin. And he took that piece of work, including some of the work by a gentleman called Adam Beck in 1997 on how to, which was called this algorithm Hashcash, how to make sure that people don't flood a system. Like think about spam emails. If you were to get 10,000 spam emails, and then out of the spam email, there's only one that's valid. It's not easy for you to see. You can lose emails. So that actually is a problem that was solved through Hashcash. So in 2008, after the financial crash, I don't know if all of you, most of you were old enough to know what was going on in the financial sector, but at the time I was actually working for a central bank. I remember this like it was yesterday, when the global financial system crashed before our eyes. And that's when on the 31st of October, which is like 2008, this white paper by a pseudonymous character called Satoshi Nakamoto. We say it's a pseudonymous character because we don't know if it's a man, it's a woman, it's a group of people, but we saw this peer-to-peer cash, electronic cash system, which for the first time gave a very tangible solution to the issue of saying, how do you avoid double spending with electronic cash? So that was the biggest problem. all attempts to build an electronic cash system or payment system failed because of this thing called double spending. So in essence, what double spending is when someone take it, for instance, when the pictures on your phone, right? And you can send that picture that you have multiple times to multiple people, right? And you still keep a copy for yourself. But that it's not the attribute of money. Like with money, after you send that money, let's say your picture is money, after you send that money, we need to know, right? We need to validate. In most cases, we need to validate that you don't own that money anymore. Someone else, the person that you've sent it to, actually is the rightful owner of that money. So what happens in the current fiat system, you need a centralized authority, like a big bank. You need like a big institution to validate, to keep a ledger, but you cannot do it in a peer-to-peer fashion. But in 2008, for the first time, by the introduction of what we call the blockchain, which is basically a chain of all the blocks of transactions on the network, which was introduced by Satoshi Nakamoto, then he solved the double spending problem. That was a big event. Then in 2016, I remember this like it was yesterday. The next leap in terms of the progress, in terms of blockchain development, was the launch of what you call Ethereum blockchain. Then you ask, okay, Mandla, how is it different from Bitcoin to Ethereum? Why was that a big event? Because up to that point, most blockchains were only solving for the transfer of value, transfer of money. They're trying to be cash systems, money transfer system. But with Ethereum, it introduced what we call a Turing complete smart contract. In simple English, that means that you can actually write your own custom business rules in these contracts, these digital contracts, and deploy them or put them on the blockchain. And then these will self-execute automatically without the need of a centralized authority. Now, that was a giant leap because that actually determined a change in my own personal career. Because from that point on, I've been building solutions mainly on the Ethereum network using these Turing complete smart contracts. And then this is us now, that point. Now, what's happening? Since 2016 up to this point, we've seen a lot of use cases go into production. We've seen the launch of what you call initial coin offerings, which some were good, some were scams. We've seen in the advent of central bank digital currencies. We've seen the Bahamas launch their first currency, like a national currency on a blockchain, on a national blockchain, which is a huge leap. And we've seen China now trying to building a blockchain for a digital yuan that will be accessible to all citizens as a one store of value and a means of exchange. In that country. All right, so I've given you the history and I've given you what blockchain is, but then, okay, Mandla, how does it work, you ask? Okay, in simple terms, at a very high level, the way you interact with the blockchain, you potentially have what you call a wallet. A wallet, think about your own wallet in your pocket, a physical wallet. But this wallet, it's a piece of software that can be on your mobile phone or through a web browser on your computer. What that wallet has are two attributes. One, it's what you call the public key infrastructure, which is a public address associated with the owner of that instance of the wallet, and a private key. Now, a private key is almost like, many people say public key, private key, but I make that clear distinction that it's a public address versus a private key, because together, cryptographically, you can sign transaction, and that's proof of ownership on the network. So let's say you want to send, so Alice wants to send Bob one Bitcoin. I'm using Bitcoin because Bitcoin is the most famous use case of a blockchain. So Alice will have a Bitcoin wallet, which is this, like as I've explained, it's a software that is sitting on a mobile phone. And the most important thing is that they have ownership of the private key that's associated with the public address of that wallet. All that Alice have to do is they have to have access, or Alice needs to have Bob's address, that public address that's associated with Bob. On the blockchain, it is not known that that public address belongs to Bob. No, no, no. The only way that you know that public address belongs to Bob is because Bob has a private key that can be, but that together with that public address, he can sign a transaction that can be valid on the network. So what Alice would do, he would initiate a transaction. So during that initiation process is that through what you call that blockchain node, that transaction is disseminated to that peer-to-peer network. So you're not sending it to a bank. You're not going through the FNB bank, FNB, or whatever bank app that you're using on your phone. But this wallet, you're actually sending the transaction directly to a global network of computers. Now, on that network, you have special nodes that we call the miners that serve the purpose of keeping that network secure by primarily just looking at those transactions. First of all, they will pick your transaction and look at, okay, is this person not trying to double spend? Right? To say, okay, they have the same value, they want to send it to different people, like as you would normally do with your picture. So what they will do, they'll say, okay, great, this person actually is trying to send this value to multiple people. So they will take the first or whatever transaction on that list. Okay, they make that first one valid. And then what they will do after doing the validation, they will solve a very hard cryptographic math problem through Hashcash, which is implemented on the Bitcoin blockchain. And then after they've seen that this is valid, they will then the transaction is then conjoined with other transactions, because not just one transaction. With Bitcoin, it's 1 meg of like 1 MB, megabyte of transactions. So they will join all these transactions and put them up to 1 megabyte of transactions. And then after that, they will form what you call a new data block. That block, it has two attributes of that block. That block has a link to a previous block. And then on the block itself, it will generate a new hash, which is a representation of all the transactions on that block, and a nonce, which is basically saying you have successfully solved the hard problem and you are the first one to do it. Because this is basically the consensus mechanism on Bitcoin blockchain. It's called proof of work. You have proven that you've done the work. And then after they've successfully do that, the new block, it's appended to the existing blockchain, and the data information contained on that is fixed. You cannot change that. And then from there, with all the other confirmation, because that transaction is obviously distributed to all the entire network, then we have a successful transaction. Then Bob will receive the value on their wallet. It's a very simplified version of how blockchain operates. Let me stop here and open the floor to questions before I look at the building blocks of blockchain.
Thank you.
Any questions?
Yeah, thank you. Joel, good day. Is this session recorded? Yes, it's recorded. The question from TT, are these linked lists? He may explain further if the question is unclear.
No. It's very clear. It's very clear. Are these linked lists? So I say the blockchain is just a linked list. You could say that either from a com side, but it's a backward linked list. So basically, the way it's linked in such a way that the current block is linked to the previous block, and it's linked to the previous block up until the initial block, which is called the Genesis block. So it's a backward-facing linked list. It's not like a forward linked list. It is a linked list, but it's linked in a historical way. So that at any point, if you try to break the chain, right, you almost need to revalidate all the subsequent blocks, even the ones from the beginning, which is like, it's impossible in terms of computation, and given how much, if you look at the hash rate of the Bitcoin network, it's just practically impossible, but you can try. Another question? All right, let me proceed. Now let's look at the
I may just say, sorry, maybe I may just say yes. Colleagues, they can type in or they can raise their hand, and then if they feel like maybe the writing may not clearly articulate their question. So you have opportunity to raise your hand, and then we'll give you opportunity in between to ask those questions. Thanks.
Okay, perfect. So I will leave it up to you to just moderate that, and because I'm not looking at that, I'm just looking at my slides. Okay, great. So now let's look at the building blocks. I am using, again, I'm using mainly the Bitcoin blockchain as an anchor here. But all these, the principles are valid for all blockchain types. So it's almost like Bitcoin is the granddad of all the Bitcoin blockchain. Let me make a distinction there, because there's a Bitcoin currency and there's a Bitcoin blockchain. So in this case, we'll talk about the building blocks of what makes up a blockchain. Okay, great. So I've already spoken about this, the public key infrastructure. So when a transaction happens, is that an Alice and Bob situation that I've made an example of is like Alice has access to your wallet, but most importantly, what they have is they have a private key that's associated with value, with Bitcoin, with whatever store of value they want to send, or in this case, Bitcoin. So they have that private key, and the other thing, they have a receiver's public address, which is like your physical address, like your if you think about in banking terms, like you have like your account number in a sense. All right. So what they do here is that when they send a transaction, it's basically there is no way on the blockchain that says, oh yeah, no, this is Alice's address. It's unless we know on a public record somewhere, or Alice publicly discloses that, hey, here's my address. There is no way of knowing whose address it is, except through mining that information and doing some social engineering to figure out whose address it is. On the blockchain, we're dealing with public keys, and then people that want to prove value will have a private key that's associated with that asset class. This is true for every asset class, whether it's your identity blockchain, whether it's your ERC20 token or whatever. You prove ownership through having a private key to a public address. So that's the first building block. The second building block, again, it's not new. It's a one-way hash function.
Sorry, Mandla. Yes. There was a question when talking about the public keys, right? Mohaji wants to know, if I may ask, who issues the public addresses and the private keys?
It's your wallet. So the thing is that the issuance of your public address is based on, when I say your wallet actually has built-in mechanism to say, when you sign up, it generates, when you install this public address, it will take you through this process of generating a seed, what you call a seed phrase, and then from there it will just give you a private key that's associated with that public key, and it's associated obviously to the specific blockchain network. So there is no centralized individual that does that. You will go through a wallet, but on a blockchain, there's countless number of these public keys that are readily available. But the wallet, which is basically interacts directly with the node, which is the ledger of that blockchain, it's responsible for basically generating this. But if you're going through, I think, Mohadi, that's a brilliant question. If, let's say, for instance, you say, okay, great, I want to buy crypto assets, I want to buy, and you go through what you call a crypto exchange. A crypto exchange will give you an interface, and they'll call it a wallet. But you need to remember one thing about crypto exchanges. Crypto exchanges are like banks, in a sense that they basically, when they give you a wallet, it's actually a wallet that's associated with their solution. So it's centralized, So on the crypto exchange, yes, you don't really own, because you don't have access to your keys until you decide to send it out. You say, I want to send this Bitcoin to my other address to send it out. Then they'll make it. But otherwise, most exchanges function like banks. So they are responsible for basically generating those wallets for all the customers that are on that exchange. And in most cases, you see that in these exchanges, they will generate what they call a hierarchically deterministic wallet, which is just basically saying they have a root key that's sitting at the top, and all the subsequent customers on the network will actually have child keys that are associated with the root key. All right, but anyway, like any wallet software is actually responsible for generating these these new keys or public keys based on what wallet software you select. But you must be very careful what wallet you install, right? Because one wallet is actually there is no good wallet. There's some wallets which have weaker security, there's some wallets which are have better security, and some wallets actually you can have hardware wallets. I'm talking in this case, like I'm making an example with software, but sometimes you can have a hardware wallet like Ledger Nano, which works exactly like in a similar fashion, except that it is what we call air gap, it's not connected to the internet. All right.
Yeah, the follow-up question from Walter. What manages these keys? I'm not sure whether you already touched on it, but that's the question from Walter.
So you need to manage your own keys. In this case, remember on the wallet, they will show you your key. So they'll say, oh yeah, here's your key and here's your seed phrase. Notice they'll give you a seed phrase. They say, put this key somewhere safe. In case, because what happens is that when you have the software, like say you have a wallet, sometimes you lose your phone. Then you ask, what? I've lost my phone. The only way that you'll be able to retrieve that wallet, or it's if you can provide what we call a seed phrase. The seed phrase is actually just saying, okay, this is it's a next step of proving that you actually own that private and the private key to that public address.
Okay, right. And of course, you will also advise us in terms of the questions that we answer, whether you will address them going forward or immediately, right? There's a question from HE.
Yeah.
He said, how can you advise one on how to know which wallets are more secure than others?
All right. Okay, great. That's also a good question. So if you go, like, let's talk from Bitcoin perspective, right? The biggest thing is that you always need to go to bitcoin.org. They always have a list of the approved wallets. So in most cases, for me, it's also a personal choice. I always go with the tried and tested. If Manda launches a wallet tomorrow, please don't use Manda's wallet until it has been proven and it has stood the test of time. So for me, you always go to bitcoin.org and you see that they have a list of wallets that you can use. They are approved, and these are actually vetted and verified by like very smart people. That will say, okay, this is something that can be used. So yeah, that would be my advice. And then also on the Ethereum ecosystem, again, obviously, like there's different blockchains. Like again, Ethereum.org also has a list of all most recognized wallets. And then if you don't trust any of these wallets, I'm not advocating for going through like an exchange, but I think sometimes going through a trusted exchange, like in South Africa, there's a few of these exchanges that are recognized that you can actually just use their wallet. And then it's almost like you have the better of both worlds, in a sense that you have access, you have exposure to this as a class. At the same time, you also have something that serves as a bank that you have head office to complain. Because the thing is, if you go with your own wallet that you manage your own keys, sometimes when something goes wrong, let's say you send Bitcoin accidentally to the wrong address, there is no head office to go and complain. It's almost like it's over. It's game over. Like if you make such mistakes, it's game over for you. An exchange can be like a nice bridge where you're still trying to understand the space. So one way is just go through an exchange. All right, perfect. Are we happy with public key infrastructure? I mean, these are building blocks for any blockchains. I'm making Bitcoin and Ethereum as anchors, so that you can have a reference point. I don't want to talk in hypothetical terms into such an extent that you just lose your bearings. All right, great. So the other building block of blockchains is one-way hash functions. So how do you link these blocks of transactions together? The first thing is that before you can commit as a miner or whatever validator on that network, before you can commit a block to a blockchain, first you generate a cryptographic hash. You don't do it yourself, obviously. It's part of the blockchain. That when you say when you successfully validate it, it will generate a cryptographic hash, which is just a one-way function that basically it generates a representation of a block of data. So if you don't know how hashes work, there's actually like a bunch of online tools where you can just see, you can actually give it an entire document, an entire book, give this function, and then it will generate, like, if we were talking about a SHA-256 hash, it will generate a 32-byte representation of that entire document. So this is actually very, very powerful from a blockchain standpoint, because as you build on top of this ledger, you continuously link these new blocks to previous blocks through these hash functions. And when you generate a new block, you almost you basically take into account the previous hash, and you generate this new hash that represents the block of transaction in the previous hash, and then that becomes a new hash, and so on and so on. If at any point in time, let's say a malicious actor tries to make changes at any point down the chain, let's say someone goes and says, okay, great, I'm not happy, I don't want to send this value anymore, I want to go and change this transaction at block number so and so. It's very, very easy, very quick to check or to see that actually at that given point in time, that's where the transaction was appended or was changed. Because any change, even if you add a space to a like what you call a digest or to an input to a hash function, it changes the hash completely. And then in blockchain, because all the hashes are linked, all these blockchains are linked, it will invalidate every subsequent block in the chain. So this is actually huge in blockchain terms as a building block of blockchain.
Okay.
All right.
Yes. Mandla, there is a follow-up question, and then I also maybe add one more, right? Is from HE also. Just a follow-up on how to determine a secure wallet.
Yes.
The list you referred to, are they assessed against a certain standard before accepted? What standards, of any, are they assessed against? So maybe other question, I just wanted to check. Can you maybe let us know what are the blockchain stakeholders? Is me, the wallet provider, a wallet assessor? What are the key stakeholders around this? When you want to do transaction, which areas? Yeah. So let me just ask that question. What are the key role players? Maybe I'll say.
So the thing is that the biggest role players in blockchain is the engineers, right? Like because this is all open source software. You know, first of all, is the big role players is the engineers that build the software, and then it's miners. You know, miners that actually their role is to make sure that they keep the blockchain secure, right? They validate transactions on the network. So if you enter transactions, they'll say, okay, great, this is a valid transaction, and then they will, I mean, in terms of proof of work, they will compete to prove, to generate a cryptographic proof before committing the transaction or the block to the chain. So in terms of the standards on what to look for in terms of the wallet, remember, every blockchain, especially Bitcoin, because they are almost like a pioneer in the space, they have a set of what you call these improvement proposals, you know, that actually includes what comprises a secure Bitcoin wallet. You know, what does it have to have? You know, like things like because a wallet is just a representation of someone that runs a Bitcoin node and allows people to go through this node to commit transactions to the network. That's just what it is. And then based on this, what you call a BIP or Bitcoin improvement proposals, they are a set of standards that govern a wallet. Like for instance, they will say things like hierarchically deterministic wallet. You know, so when you generate a wallet, the preferred mechanism is that you need to allow that you generate a hierarchically deterministic wallet. Even if it's just me, I I can have like a root wallet, a root address that has a subsequent child address. So in that way is that I'm not linked to just one address, you know. So I have multiple address, but it's just linked to this root wallet. That's one. The second thing is that when you generate a wallet software, it must be what you call a segregated witness compliant, SegWit compliant. Again, which then means that when I send transactions, because the thing is, when you send a transaction on a Bitcoin or on the Bitcoin blockchain, is that there's transaction fees that you have to pay. You know, like what's why wallet providers typically make money through them, the transaction fees. But now, if like I said initially, is that because it doesn't use what looks like an account number, it uses what you call, like, it uses a block, like it's the size, like a block of transaction is 1 meg. So let's say a wallet is not SegWit compliant, which means that the way the wallet provider aggregates transactions and commits them to the blockchain, it's actually expensive, which means it will cost me more. You know, as an individual person that has a single transaction, a transaction will potentially cost me a lot more money. So they are not optimizing them. So that wallet is not recommended. You know, so they look out for things like that, and they'll tell you, okay, this is the wallet that you have to use. So there's engineers that are under the Bitcoin, Bitcoin.org. It's a community. It's not a company. It's a Bitcoin.org community. The same thing with Ethereum, because it's a community. So they'll make recommendations based on what they've seen in that wallet and what that wallet is able to do. But ultimately, the choice is yours. Remember, this is like complete decentralization, because you can't go back and say, oh yeah, no, you're Bitcoin.org, you're the people that recommended that wallet. Now I lost my money using that wallet. I want my money back. They'll tell you, like, no, go jump. Because again, it's opinions. It's based off of their opinions. All right, great. Any other question?
Okay, there's one here. It's not necessarily to be the last one. No issues with asking. He's just saying, I promise this is the last question. Let's use example on the hashing. What is the minimum acceptable hash function strength a wallet can use? And how can one determine if a wallet is using a stronger hash function? It should not be necessarily the last one.
All right.
HE, I'll just call it HE, yeah?
Okay. So remember, when I talk about these wallets, I'm talking about the building blocks of blockchains, not wallets. I'm talking about blockchains here, right? And a public key infrastructure is part of the wallet aspect. It's just one piece that works out to build up a blockchain. And when I talk about one-way hash keys, it doesn't involve, so the end user doesn't even care about this. In most cases, you don't even care about the hash functions. Right? They don't impact you at all. You know, in most cases, when you just transact and send value, you don't even know about this one-way hash functions. I'm talking about them as almost like a knowledge sharing, that like a blockchain is made up of this, a public key infrastructure, and then there's one-way hash functions that basically make it a chain of blocks of transactions. You know, so you don't have to worry. There's no work that's involved from an end user perspective. So you don't have to worry. But if we're going to get technical and say, okay, then Mandla, why SHA-256, which it's the most widely used hash algorithm, SHA-256. We say, okay, we have SHA-512. Why SHA-256? You know, why is that the one that's implemented? So in terms of security, the SHA-256, the SHA-512, they give you the same level of security, except that with SHA-256, it's a 128-bit it digests. So it will generate in byte terms, you're going to get a 32-byte character string, which is manageable in blockchain because it's short enough, right? And it's secure. It's still short enough that it doesn't take too much storage, or it doesn't have like a big footprint on the blockchain, because you're going to generate a lot of these as you generate blockchain transactions. So it's short enough and it's secure enough, you know, unless there's a quantum computer that's introduced, which is, again, SHA-256 should be good enough. It's just a matter of now, how do you update the difficulty level? in terms of that cryptographic problem to solve before you can generate a nonce that you'll append to that that hash function. So it's the choice here was just a matter of like, especially with Bitcoin, the thinking was that you need, because this thing it's gonna grow over time and become as big as possible. You want to make sure that the footprint of every single thing, it's not big. So it like has to be as small as possible. That's why like a transaction, a block of transaction has to be max 1 meg. It cannot be more than that. You know, they tried in 2017, like with Segwit 2.0, like, or Segwit 2x rather, like we need to increase the block size. They're like, no, that failed. You know, so it's that aspect that it's one security, and the other thing is the footprint of the digest or the output of that of that hash function. So they took that into consideration. All right, great. Should we go to the consensus mechanisms?
Yep,
Happy?
please.
Okay.
Yep.
So the other building block of blockchain is what we call the consensus mechanism. A consensus mechanism is just a set of rules that determine how one person can get the right to append a block of transactions to the blockchain.
I doubt it's me.
All right. Is someone saying something to me, or someone unmuted? So that's what the consensus mechanism is. Every blockchain, because of the decentralized nature of blockchain, you almost like the system itself has to automatically marshal or manage who gets to write or to basically append the next block of transactions. You can imagine if you have like a bunch of miners that are in China, Russia, the US, Africa, Cape Town, Nigeria, wherever, you know, it's like, great. Maybe at some point, the two people are able to solve the cryptographic problem at almost at the similar, like almost at the same time. Then who gets to be the one that writes the blockchain? You know, so it's where the consensus mechanism comes into play. So different blockchains will have different consensus mechanisms. Like a public blockchain like Bitcoin, Ethereum is changing, but Bitcoin uses what we call proof of work, which is basically the fact that you have to work. And to solve that cryptographic problem, you don't need to be clever. You need to brute force it, which brute force means that you need to have a much more powerful computing power. So that's why in most cases people will use GPUs, graphical processing units, instead of if you're trying to use like a CPU to solve this cryptographic problem, you're never gonna win, right? So that's why most people that want to form part of like what you call a mining clubs, they will, you know, put value, and people will go and buy this big mining rigs that are GPUs and try to compete for blocks. But why do you want to be part of that? Why would you want to be part of the of Bitcoin mining? It's because it's a block reward, you know. So after every 10 minutes, if you're successfully able to validate transactions and solve that cryptographic problem, and you earn the right to write or to commit a block of transactions to the chain, that's what you call a block reward, which up until May this year, it was 12.5 Bitcoin, like fully newly minted Bitcoin that you get, you know. So it's a huge incentive. But obviously after May, Bitcoin went through what we call halving. So it's no longer at 12.5, now it's 6.25. And in 4 years' time, it will go through that halving, and then it's going to be 3.125. And then after 4 years, it halves again. But that's what we call a block reward that you get every 10 minutes if you win the cryptographic reward. It's impossible for one miner to be able to do this and win every time, like the block reward. But another consensus mechanism, I mean, obviously, why do we have all these different consensus mechanisms? Is that obviously proof of work is very expensive in terms of resources because you have to brute force it, you know. At some point, it was estimated that the Bitcoin blockchain actually consumes more electricity than Ireland, you know. So there's a high electricity consumption. So for a world machine like Ethereum, a proof of work consensus mechanism doesn't make sense because there's a Turing complete smart contract and it doesn't seek to be just a financial blockchain. So that's why the migration to what you call a proof of stake, where people that hold more value on the network will potentially earn the right to validate transactions on the network. You know, this has been in progress for a while. Ethereum is one of them that's like proof of stake. There's other what you call third generation blockchains that have actually proof of stake consensus mechanisms, and these are actually in production today. One of them is Tezos. They use a variation of proof of stake, which is delegated proof of stake. What that means is that it's just basically saying if I have enough value or of these tokens on this network or on this blockchain network, I can delegate my voting right to someone else to say, okay, Motlokwe, because you also have your value, you have stake in this network, take my vote and then let's vote for the next valid block of transactions. There's issues and there's things that that are being solved with proof of stake, but proof of stake has been the most viable alternative to proof of work as a consensus mechanism. I can go into detail with the other ones. I think the other interesting one is what called proof of authority, which I've worked quite extensively with. Proof of authority consensus mechanism works mainly in private permissioned blockchains where you actually know the participants. You know, like with big companies, big banks that are implementing blockchain solutions, but at the same time, they want to be validators on the network. Proof of work doesn't make sense. Proof of stake doesn't make sense. But you use what we call proof of authority. By virtue of you being who you are, we can, to a certain degree, trust you, but not fully trust you because still it's practical Byzantine fault tolerant. So in other words, it's like if one of these POA or proof of authority validators were to become malicious, we are still able to detect that, and the blockchain doesn't go into a state of being locked and not progressing to the next level. So that hence is practical Byzantine fault tolerant. I'm using a lot of these buzzwords, but I'm hoping that you understand. If you don't understand, you want me to get into detail about what these words mean, we can go through that. But for now, just understand that proof of authority is just it's good for networks where there is some level of trust in terms of the participants on the network. So we don't really, we know who they are, but at the same time, we still want the benefit of saying we don't want to have a centralized authority to trust in that network. So proof of authority consensus mechanisms are useful in those kind of blockchains. All right.
Yeah, there was a question when you talked about the processing, right? I think this, Walter, I don't think maybe we need to elaborate more, but just say, is quantum computing not being used for processing?
No, I think we're still, okay, quantum computing, it's still in its early days, right? So many people are saying, oh yeah, no, quantum computing will make blockchains invalid or useless or whatever. But quantum computing is still, I mean, I don't know any production grade a quantum computer that's being used. I know IBM has a quantum computer that it's still pretty much in their incubation. It's still, you know, like it's still experimental. We're not there yet. But yes, maybe in the future, quantum computing will be a big player in terms of, will have a big impact in how we build blockchain networks going forward, especially the consensus mechanism aspect of it. All right, so I spoke about mining in proof of work. I don't know if I think I've gone through this to a great detail, like how verification of transactions, how you group transactions in a candidate block, and then you insert a hash of that block, of the most recent block into the candidate block, and then you solve for proof of work, and then get the block reward if you're the first one, and then from there you go, and then obviously you attach that candidate block to a local blockchain, and then you propagate the block to the entire blockchain, and then you await basically the verification by other nodes. This is just like a levels of confirmation. The smaller the value, the quicker the confirmation. The bigger the value, the slower the confirmation. Confirmation just means that that transaction cannot be reversed on the blockchain. right? So the more confirmations you get, the more you can be confident that that transaction cannot be reversed. Because otherwise, if some nodes feel like, okay, this transaction is not secure, it can still be reversed even after successfully committing that to the blockchain. Okay, great. So before I get into some of the use cases, I want to just touch on the myths of blockchain technology. So there's more, but these are the ones that you will hear. Like number one, people saying blockchain is Bitcoin. And I mean, if you misconstrue what I've been saying, all this, you'll think that I'm saying Bitcoin is blockchain or blockchain is Bitcoin. No, it's not. Bitcoin has a subset of blockchain. Bitcoin introduced blockchain technology, as a mechanism to make sure that you prevent double spending attacks. So it is the most famous application of blockchain, but it is not blockchain. So blockchain technology in itself we've seen it can be used and configured for various applications and use cases. Another one people will say, especially blockchain purists will come and tell you, like myself, blockchain is better than traditional databases. Initially, if you were to talk to me early 2015 or 2016, I'll say definitely. But today I have learned that no, actually there's use cases where sticking to the traditional system or traditional databases actually has significantly more benefit than implementing a blockchain. Because blockchain, number one, especially these custom blockchains that they build, private permission blockchain, they're very expensive to maintain. And there's definitely like trade-offs that you need to, like the skill set and the infrastructure that you need to use. It's the biggest use case or benefit of blockchain. It's in environments where you need to almost decentralize trust. Like you trust institution, like there's a figurehead in there that you have all the trust in the world. So if you want to almost like decentralize that trust, then blockchain is powerful for those. Like, for instance, the transfer of value, identity is one of those. Land registry is one of them, which is something I'm going to touch on just now. The other thing they talk about blockchain being immutable or tamper-proof. Yeah, by and large, yes, some of these public blockchains are, but in general, if you can get 50% of the network computing power of that entire blockchain, you can change the rules of that blockchain, and ultimately rewrite history. With Bitcoin, it's impossible, but there's many blockchains that have been launched with the fewer validators that has gone through what we call a 51% attack. Where some individual or a group of individuals gain more than 50% computing power of that blockchain, and then basically rewrite history and rewrite the rules of that blockchain. So not all blockchains are immutable or tamper-proof. And the other thing is that blockchain is 100% secure. No, that is not true. Blockchain, it has those immutable data structures, and it uses cryptography and all those, but the security of that network is dependent on the participants, right, of that blockchain. So it can actually be attacked and breached. The other myth is you'll hear a lot about people that have not implemented blockchain solutions but are big advocates of it. They'll say blockchain is a truth machine. It's not. A blockchain can only validate what's natively on the blockchain. It's very good for natively digital assets that don't need any proofs from outside of the network. It's a lot harder when it has to deal with the physical world, right? Let's say, for instance, you have, with DeFi, you get a lot of this where there is, the concept of stable coins, for instance, like you generate this cryptographic token that represents fiat currency, which means that you need to know what is the price of that fiat currency. So, which means you are dependent on the external world to give you that information. So in blockchain terms, we call that the Oracle problem. Oracle, there's a distinction. There's an oracle, that is the company Oracle. Oracle here are people or external entities that feed world data into the blockchain and potentially determine the state of some of the blockchain tokens and assets. So in other words, it is a lot harder. You'll hear people telling me about how blockchain will solve all these supply chain problems. Things like, okay, for instance, I can tell where the fish was and the temperature, and if it was stored. Yeah, you can, but you depend on what we call the oracles. In this case, you depend on these Internet of Things devices to feed the information. And the assumption is that the people that are actually even monitoring those devices are honest people and they can be trusted. Again, blockchain is not strong in this case. So blockchain will only take whatever it's fed and then do computations based on it. So it's actually much better with natively digital assets versus where it has to get information from the world. There's more, but I just thought I should keep it at 5. Any questions on this?
So far,
nothing.
Yeah.
Okay, great. So now let's look at the practical blockchain. I like this quote from Roy Amara. It's like, we tend to overestimate the effect of a technology in the short term and underestimate the effect in the long run. So if you look back in 2016, everyone wanted to build a blockchain. Blockchain could solve everything. That's the overestimation of the effect of this technology in the short term. It's like everything must go in the blockchain. That's a bubble. Most of those solutions or those initiatives failed. However, fast forward a few more years. Today, you see central bank digital currencies. You see big institutions buying or stockpiling crypto assets as a hedge against fiat currencies and inflation, etc. So you can see that in the long run, the adoption is actually happening. Since now, initially blockchain was about, this smart engineers and cryptographers wanting to create an alternate universe. Right now, you see institutions that are interested in stockpiling and also building blockchain solutions. Most banks in the world are actually launching their own stable coins, the blockchain networks that are interoperable with one another. So the opportunities in this space are endless. Let's look at these benefits of blockchain. The biggest benefit of blockchain is the transparency. In most cases, the current system or centralized system, there is no transparency. When you send money to me, you don't know what's going on until the other person can confirm that, oh yeah, I got the money. Oh, great. So something good. But blockchain gives you that transparency that you can see the transaction. Like with Block Explorer, you can see the coins I've sent last time, as long as you know my public address. It's timestamped. So timestamping is such an important thing. This is true for documents, true for values, for videos, for everything. Timestamp that this thing happened in this particular time and date. And it's part of the metadata of that document. So blockchain gives you that, the timestamping, and you cannot change that. You cannot rewrite history. And the other point is decentralized. The fact that there is no central or authority or central entity that you can trust. So everyone, you trust the network, you trust the math, the algorithm of the blockchain over individual. So that's a big benefit. And the other thing is transaction finality. Most cases you hear people when I say, actually, blockchain is much better for cross-border remittances. They'll say, no, but Visa and whomever, they are doing this at a higher scale. Yeah, but remember, these guys actually, there's the settlement, and there's also the there's the settlement aspect, which Visa doesn't cater for, right? So transaction finality, it's so important for that fact that when a transaction has been signed, cannot be reversed. That's what blockchain gives you. And speed of transaction. Like right now, if you were to send, let's say you want to send money to someone that's like in India or wherever, You know, let's even use Venezuela as an example. You are lucky if that person gets the money on the other side. But with blockchain, within potentially a day, like 10 minutes or two, like based on how much transaction fees config you put in your blockchain, that person can actually get the money or the value within like a few minutes. Resilience, you know, there's huge aspect of resilience. Look at Bitcoin has been live for 10 years. There is no centralized authority that owns a Bitcoin blockchain. It's all decentralized, and it's been live for years, and it's still going strong. The same thing with Ethereum. You know, there's that resilience. A confidentiality. If you build confidentiality in, you can build confidentiality into blockchain. There are confidential blockchains. You know, like secure blockchains, like Monero, like Zcash, where you basically, as much as you can see a transaction, you cannot actually see what was in those transactions. You know, as traceability of transactions. You know, you don't trust a single entity to basically show you what happened. You can see on the blockchain through various explorers to see when transactions happened and from where. You know, so those are the big benefits of blockchain technology. Right. So some of the use cases that I have particularly been involved in is number one, the land ownership registry, which it's such an important human rights issue, where right now you have the deeds office that you trust 100% to keep a registry of this. But also there's also an informal sector of people that build houses on the side, and then they all don't have a title deeds. You know, that's where blockchain actually shines, where you don't have to trust the central authority to manage a registry of these deeds. There's countries like Uganda and some in Georgia in the States, where again title deeds are already logged on a decentralized network. Another use case services, cross-border remittance, trade finance, syndicated loans. Again, these are big use cases that blockchain has given huge benefit to the financial sector, and I'm so privileged to have built some of these solutions for commercial banks and central banks here in South Africa. And the other one is identity management. There's blockchain clients purely for identity. You know, like how do you, for issuance and management of identity. At the moment, you trust the government to issue your identity. There's nothing wrong with that. But in future, what you potentially want is that your whole identity is actually issued on a decentralized ledger. And this becomes imperative and important in countries where there is no stability. You know, I mean, in 2018, 2019, there was a project that was called ID 2020, which was seeking to create this decentralized network where you can issue identity for refugees. You know, so it becomes powerful, especially for nation states where there is no, and actually even for your future as well, because if you have what you call a self-sovereign identity, you own your own identity, so it means that you can choose who can access your identity, who can see where you live, your information. At this point, for instance, if you open an account with entity A, you almost have to provide the same information, like what you call in a process called know your customer. You need to provide the same information with that entity A that you've given to entity B. As to what they do with your information, you are at their mercy. That's why, for instance, if you ever ask yourself, why after you've registered for, maybe subscribed to a certain service, suddenly you get another service provider calling you to sell you something else. Who gave you my information? Right? But now, if in a self-sovereign identity setting, which I'll show you some of the blockchain clients, and we built something actually in this for self-sovereign identity, is that you choose who you want to share your identity with and which record you want to share with, right? So if I want to open like a let's say a mobile phone subscription, I don't need to give you my how much I owe my municipality, as a proof of residence. Why do I need to do that? So blockchain solves this problem. There's other use cases, and the use cases are vast. I'm just going to run through this one, like the categories of use cases that we see emerging in the space. The one category is basically around record keeping, just to prove the validity of records. Like if you look at how many people that fraudulently or automatically have these PhDs and stuff that they got off of the internet. A blockchain becomes very important, that you can see that, okay, this actually was issued by a trusted entity and it's on the blockchain. Yes.
Yeah, there is a view that I understand we are running out of time, but I think I'm talking, they say the pace, I think the pace is too fast for some of us. Yeah, I know we have 10 minutes, but yeah.
Must I slow down a little bit?
A bit, not that much, but yes. That's
all right.
Yeah.
Okay, that's fine. Okay, great. So if we look at the categories of blockchain use cases, there's one category which is around record keeping and storage of static information. As I made an example with the registry of your title deeds, you need that. There is no magic that happens with title deeds. It's only when you want to look it up to see who owns these title deed at this given point in time. So someone can have a physical copy of the title deed, and then you can scan maybe a QR code that's associated with the public address that's on the network, and then you can prove ownership that this is actually based on the record, it's owned by this person. And I spoke about identity, again, which is looking at people's identity. I lost my ID book right now. So ultimately, I can be, I'm illegal. Someone would come to me and say, produce your ID book right now, right? I'm illegal, but I have my phone, right? That I can show someone else. Scan this QR code, then you can get my ID. You can see that I'm actually a citizen of this country that I'm in. The other thing is around the smart contracting. Smart contracting it's so important. And I've seen this, and the more I use smart contract, the more I build smart contracts, the more I realize the infinite power of these pieces of code that you can distribute, you can deploy on a decentralized network. Smart contracts, like for instance, right now, if you want to say, I want to generate a will, for instance, right? Like a will, like you need an executor, you need a lawyer, you need all these people, and then from there, after you've signed and agreed who's on your will, that will becomes a document that the lawyer goes and keeps somewhere. You hope and trust that that thing, wherever they've kept it, it's not burnt out. And there's 100% trust on that the lawyer, upon your death, they will be honest, right? Smart contracts, almost in the future, I foresee this being deployed on smart contracts, where you can say, based on 1, 2, 3, 4, 5 conditions, and I am not responsive, do this. Distribute my funds, do this. It's all on the blockchain. You don't need to trust an individual to do that. But obviously that's like far off in the future. But I see the future being possible. And today we have this thing that's called yield farming, where holders of a crypto asset, let's say you're a holder of a Bitcoin, like where you have Bitcoin that's sitting there, it's not any interest except for the movements that are happening, right? So you can actually commit this Bitcoin to a smart contract that will go and find systems or other contracts where you can actually earn an interest on the Bitcoin for doing absolutely nothing on your side. This is like the power of these smart contracts. And then the others category, like subdivision of the categories, when it comes to transactions, that the registry of tradable information. The one is what we call a dynamic registry, where you have like this dynamically distributed database that updates as assets are exchanged on a digital platform, right? So the state mutates as these assets are exchanged. And the other, it's the payments infrastructure, something that's very close to my heart that I've been building for a few years now. It's about like the thing around cross-border remittance. How do you simplify that? How do you send value if you're in South Africa, you want to send value quickly to someone in another country without too many hoops and that you need to jump before that person ultimately receives that value. There's other use cases that are in this space. For instance, I spoke about the initial coin offerings and something that we built based in early 2017 that now has become very prevalent, a blockchain as a service platform using cloud computing and putting these things so that you don't have to do the infrastructure investment. So you can just subscribe to this blockchain. That's a service online that you can easily just provision a new network and connect to other participants on that network. All right. Again, the speed, the world of blockchain. I'm not going to spend too much time on this slide, but it just paints a picture of what's going on in this blockchain ecosystem. You see peer-to-peer lending. I've spoken about the remittance, like e-commerce, global payments. I've spoken about, like another thing, like the escrow service, where, you want to transact or exchange value with another person. But at the same time, you want certain conditions to be met. You can use, instead of getting a physical escrow, you can use a smart contract that can serve as an escrow to do this, to facilitate this mechanism. Today, if you're following world politics in the US, that's a big thing about voting, like voting by mail, there's mail fraud and all these things. Blockchain solves this problem, where you don't need to send your vote through the mail. It's about, it's this ledger that can be decentralized and everyone can actually just vote. And then it's anonymous in a sense that obviously it still uses public key infrastructure, and you just vote for your candidate. Obviously, this has to be built in line together with like self-sovereign identity, where obviously we can prove that you are a citizen of that country, but at the same time you can vote without the need to worry about like mail fraud and going to stand in queues, etc. But another big use case that I've not spoken about, it's about the healthcare, the health record. Build solutions in this space where you, right now, your health record sits with various people, various doctors. As you see a doctor, they will create a file for you. So your information is basically distributed across many medical practitioners. Blockchain can help with this when you can implement this health record. As you see as you visit a health practitioner, your record gets committed to this network, which is it's immutable, and you can see historical transaction as you see historical visits, and you can actually use some AI or reporting mechanism to see like what seems to be an issue with your health, if there is such a thing. All right, so I don't want to spend too much time on this, but a few years ago, McKinsey and company, they basically did a study where they looked at what are some of the industry that whose fundamental functions are inherently more suited for blockchain solutions. But I mean, you can see now here in terms of agriculture, the dots represent where it's high and high, medium, low, etc. This is a picture that paints that just about every industry will be impacted by this technology. All right. Basically, if I were to conclude in terms of the high value use cases for blockchain, most cases you want to look at where there's a shared repository, where you want to share this share data across various participants. And then it also must allow multiple individuals or multiple people to write on the ledger. And the other, it's minimal trust, where there is no, it's very minimal inherent trust between the participants of this network. And also there's intermediaries, the people that are always serve as an intermediary. Like you can also disintermediate all these intermediaries on this with the solution, the blockchain solution. And there's also like that transaction dependence between the participants. So potentially all use cases that basically tick those boxes will be best suited for blockchain. Great. So this is just something that I'm going to also just run through it. Let's say you want to build a blockchain for your industry, for your place. How do you decide, okay, if this is actually a solution that's suited for a blockchain? So in most cases, engineers and people that build are most excited about a piece of tech. They do a technology-centric approach, where I want to build my own blockchain and then I tweet about it. But in most cases, you must always identify value, whether it's business value or value to humanity, and say, okay, this is the problem that I want to solve. And then always, when you build a blockchain network, you're building for the ecosystem that you're in. It's about the industry ecosystem that you're building that blockchain network for. It's not just for yourself. Always think in terms of the entire value chain. You know, instead of like saying, okay, I'm just want to build a blockchain for the education department. Always think about who's processing the payment processors. If there's another party, think about the entire ecosystem and how the participants will participate, will actually add value to that network. And the other thing is, it's about designing deliberately. Be very deliberate in your design. What do I mean by that? I mean that always have a finite scope. That, okay, this is the one thing that I want to solve. Don't solve everything in the world. Just solve for one thing. And then always build iteratively. Actually, that second line has to be like, build iteratively. Build a small piece and then deploy and learn something and then build again. And if you build a solution, always make sure that you're on the right-hand side of the regulators. I've learned this the hard way, where you try to build and then like very late on in the process, you want to engage with the regulator. The answer will always be a no from the regulator. So always when you have an idea you want to build and you want to solve this thing, understand what the regulatory implications are. All right, so before you decide to build your own blockchain, there's a lot of blockchain clients that are already in the public domain. This is all open source software. And the networks that are published here, that are listed here, these are just the blockchains that I've worked on, excluding Bitcoin. These are custom blockchains. You know, Ethereum, Quorum, which is more suited for what I call proof of authority networks, companies, Hyperledger Fabric, Hyperledger Indy. When I was talking about self-sovereign identity blockchain, Hyperledger Indy is that blockchain that allows people to to have custody of their own identity and decide who they want to share it with. Now, Stellar is another blockchain that it's good for payments and public transactions. Corda, it's strictly speaking, is not a blockchain again, but it's what we call a distributed ledger piece of technology that, for some reason, some banks love so much. Another blockchain.
Yes, you are breaking a bit.
This is all open source software that you can just go. Hyperledger base you avoid quite breaking. That's because it's raining. Goodness. One slide, and then look up these networks. And
we can hear you. Some of us can hear you.
Oh, you cannot hear me. My goodness, let me see.
We can hear you. Some of
you can hear me. Okay, great.
Yeah.
Okay, thank you so much. So what I'm saying is like my advice: go look up these clients and learn how this network works, and just do it for yourself and just get in, and that's how you learn. Yeah, so basically that's the end of it, and it just started raining here. That's the end of my presentation. Thank you so much for your attention and for listening. And I hope I didn't lose you. And I hope you got something, just one thing from this presentation.
Yes.
I don't know, Motlokwe, do you want to take questions?
Yeah, there's one question here, and maybe friends may add the additional ones. But we are, can blockchain technology be exposed to a risk of unsustainability in the future? This was coming from Walter.
Walter, the risk of unsustainability, yes. It's just based on what blockchain, in terms of the managing a blockchain network. I say it's if you build like a custom, what you call a permissioned blockchain, it means you need to have the infrastructure to manage that node. And remember, because blockchain is immutable and it grows over time, is that it will grow in exponential form in terms of the size of data. At some point, you'll have to decide how to archive, etc. So yes, there is a huge element of being unsustainable. However, in terms of the promise and the solution that it offers to our world today, it's just worth it. You know, it's hugely worth it.
Right, there is a
Any
question.
other question?
Yeah, in
Yes.
South Africa, do we have a bank that has implemented blockchain that we may know of?
Yes. Yeah, there's many banks. There's like, I mean, every single bank, like today, all the big four banks have some blockchain solution. You know, so I cannot go into detail as to what kind of solution, but most of them already have. It's either they have something in production or they are well on their way to launch something in production. That's blockchain based, yes.
Yes, Mandla, I think the issue about the career, just maybe you can just touch. So I think you talked about this. It seems that there's an element of the technology, but you need to understand all this other environment that you operate in, and there are lots of things. So then, can you just touch quickly on the career element?
Yeah. So, yeah, thank you so much. I was hoping that I will get into much more detail, in-depth detail, in terms of what are some of the career opportunities. So, let me just say, every single, whatever you're doing today, whether you're an engineer, you're an analyst, you are a technical writer or a writer, there is a place for you in the blockchain space, because what blockchain is happening, it's a paradigm shift from when things were centralized to a new and better decentralized world. You know, I've had one of my best friends, he studied English, you know, but today he works with one of the biggest blockchain companies in the world. So it's actually, it's not a matter of whether you need to change your career path. So what you need to do, just think about what you're passionate about and think about that in a decentralized fashion. There's a huge skills gap in blockchain. Every second day, I get someone in my LinkedIn profile offering me a blockchain job somewhere, right? Oh yeah, we're doing this blockchain, we need someone. So it's like, this is one field that is still very green, and there's very few people in here. And if you really want to get in, right? Especially around building smart contracts, validating smart contracts. If you're already in ComSci or you already understand databases, it's such a big field where you can really have a rewarding career. And I mean, if you're also interested in education, where you want to teach, I've traveled the world, you know, like different areas of the world where I've given, I mean, through invite, you know, where I've given public, obviously public talks, and others like in like private training sessions to companies and to some governments around blockchain technology, because it's such a nascent technology and many people want to understand it. You know, there's always that need globally. They know that this is going to impact they impact the world, impact their country, so they want to learn. So they try to find as much skills and knowledge and as possible. So if today you were to decide, you know what, there's something I want to get into, I would encourage you to do it. You know, like other fields are crowded anyway. So whether you want to be an educator, be a blockchain educator, right? There's not enough of those. If you want to be an engineer, become a blockchain engineer. If you want to be a solutions architect, become a blockchain solutions architect, because it's such an excellent field, and you can do just about anything. And the demand for skills and knowledge is that it's so high today in blockchain.
Oh, great. So then you're saying we can have, say, for example, typical me IT guy. So I can,
Yeah.
where do I go? The Udemy's of this world to find, or do you know any specific
Most of this
area?
information is already, yeah. That's a good good question. So what you want to do? There's a Coursera course. There's a Coursera course that I took many years ago. I think it's not many years ago. It's 2015, basically. It's from Princeton University. If you want to get, I mean, today I was just touching the surface. If you want to get deep into blockchain, just understand, get people that will paint the picture so well for you. It's free, right? If you want, you can get the certificate, but just do it for free, and you can start there and learn. And the other thing that also will push you to it's get into there's consensus. I'll send the information. I can send you a list, or links that you can go and learn and educate yourself. There's one of the cryptocurrency exchanges. It's called Binance. They actually have what they call Binance University. Most of the content is free. You don't need to pay anything. They will explain to you things like what is blockchain, right? They'll go into depth to what blockchain technology is, and cryptocurrencies, tokens, and token economics, and all these information is offered for you for free. You don't need to pay anything. If you have some money that you want to, just say, okay, I want something much more formalized, etc., you can go through Udemy, and there's a university that actually offers a qualification, a blockchain qualification. A few universities already offer this, but so you can basically sign up for a degree in the space, and get officially. But I can tell you, most of the things that I know, I learned by doing. I'm pretty much I'm obsessive about. I need to learn by doing. I need to do it myself. I don't want to hear Mandla telling me that this is possible. I want to see it by myself. I don't want to hear someone telling me that I want to do it myself. So one of the maybe the last, or the best pieces of advice that I can give you today is learn by doing. Do it yourself. Ultimately, that's how you learn. Make mistakes. Those lines that I've given you, learn from it, and and ask questions. Some of these people, like myself, that you'll find online, they're willing to give. I have a few young people that have asked me. They've asked me questions about blockchain. When I have time, I do jump on a call and just explain some of these things in detail. But if you want to jump on this. This is a huge space where you can grow.
Great. Thank you very much, Mandla, for great presentation and the insights and the experience that you shared with us. I've learned personally a lot, and I'm hoping that the friends who are still with us and those who are with us, they've learned a lot. Thank you for making time to be with us, and we are hoping that maybe in future we might have a boutique session where we'll deal with the issue in more details. But yeah, indeed, thank you very much. And for those who attended, we really appreciate your time. I'm not sure if there is any parting word that one need to say. Yeah.
No, that's it. I just want to thank everyone for coming through, for spending the time. I know it's a bit difficult, obviously, with COVID and the fact that it's streaming online, etc. It would be nice if it was in a location somewhere, and then you get to ask me some of these questions in person. But this is still the best, and kudos to you, Motlokwe, for setting these sessions up. It's very good because it just makes it very relatable. These pieces, these fields, or these technologies. So kudos to you. Well done.
Thank you very much. Friends, without any waste of time, I think we passed by 15 minutes or so. Thank you very much for joining, and remember that next week, the 8th, we are talking about machine learning, and the week after, we'll talk about project management, and one of the presenter is Mr. Augustine out of Tanzania will be joining us on the project management. So thank you very much. Keep in touch, keep safe, wear the mask, social distance, of course, wash our hands regularly. Thank you very much. Keep in touch.